Okay, so Unit 1, Lesson 2, using segments and congruence. We're going to learn a little bit about line segments and how they behave, and what congruence means, how we determine whether two segments are congruent. So to start off, we're going to start off with something called a postulate. And a postulate is a rule that we accept without proof. Now, a lot of times I'm going to be able to explain things, but a lot of these postulates you can observe and you have observed before. So this ruler postulate says the points on a line can be matched one-to-one with real numbers, meaning if you have a line, you can mark it with real numbers, right? And the real number that corresponds to a point is the coordinate of that point. So if I made a number line, I'll fix that. If I made a number line, 1, 2, 3. I know that that point I graphed has a coordinate of 2. So that's just all it's saying, is that we can create a ruler and talk about distances of points. We can measure distances using a segment. So a segment is a chunk of a line that we can measure. The distance between 2 points, A and B, is the absolute value of the difference of the coordinates of those points. So in that number line I drew up there, the distance between 3 and 1 is the absolute value of 3 minus 1, which is 2. Another way you could look at it, you could also do 1 minus 3. The absolute value of that is also 2. So finding the distance between 2 points comes down to being able to subtract them. On a number line, sometimes you can count, but I like using the math because we may be doing some work with number lines that doesn't allow us to just count, okay? So our first example is just that, using a ruler to measure this segment. So I'm going to supply you guys with rulers, but measuring it to the nearest tenth of a centimeter, the way I would measure this segment is I would line up the first tick mark on my ruler, okay, not the end of the ruler, with the, I'd say the inside of this point, okay, the inside of point C. And then I'd see what point D was, okay? So on the rulers I give you, those tick marks go like this, okay? And there's 10, 6, 7, 8, 9, 10. If you're going between 1 and 2, this tick mark would be 1.2, okay? So that's how you count a ruler. So looking at this segment, for me, if I'm going to the nearest tenth of a centimeter, the closest tick mark, I would say that this segment, if I'm measuring it with one of those rulers, I'd say it's 5 centimeters, okay? If you said 4.9, 5.1, I really want us to get down that the whole concept of segments allows us to measure things, which is a super important thing for many different applications. So we're going to talk about the basics of that today. So next, we're going to talk about another rule, another postulate, and that talks about segment addition. So what segment addition tells us is that if I have a segment and I pick a point within that segment, these two segments that make up AC, their lengths add together to be the length of AC. So let's say AB was 5 units long and BC was 6 units long. That would make AC 11 units long because 5 plus 6 is 11. So it's a pretty straightforward postulate, and we're going to put that into practice in example 2. So this example 2, it shows 2 locations shown on a straight line. We want to find the distance from the starting point to the destination. So the starting point and the destination. If they form a straight line, I mean every line is straight, but they form this segment that is straight, we can find the distance if we know starting point to rest area to destination. And I'm going to write this out using the names of the segments. SR plus RD equals SD. The two segments that make up SD add together to be the length of SD. So really all I'd have to do is 64 plus 87 equals whatever SD will be in miles. So that would be 151 miles from starting point to destination. Okay, so pretty straightforward example, I think. And I'm going to keep going with that idea of segment addition. Okay. Next example, finding a length of a segment. Now we're given different information for this example. We want to find the length of KL. We don't know the length of KL. What we do know is that JK plus KL equals JL. And the different thing here is we know JL. We know the entire length of the segment. So to find this missing piece of the segment, KL, I would just take 38 minus 15. So KL is 23 units long. And you can test that. You could take 15 plus 23 and you get 38. So I think that's a pretty straightforward way of explaining that. Okay, we take the segments that make up the entire length of the segment and we add them together to get the entire segment. So I think that this is a good place to stop and have you do some sort of activity to kind of reinforce your understanding of just the segment addition part of this, okay? And then I'm going to cover in the next video one example of comparing segments, talking about congruence, and then you're going to have some guided practice.